Okay, so today I'm going to be, hello everyone. Today I'm going to be talking about our project, SOTERIA, and how it helps providing secure software environments for scientists. So in recent years, there's been an increase in supply chain attacks, and we see them more and more in the headlines. Just to give you some examples, there was an attack on Microsoft Exchange servers around 2 years ago, which affected more than 30,000 US organizations. There was a nationwide attack through Excellion file transfer system that affected many institutions, including the entire University of California system, and also more recent ones on Okta authentication services. Traditionally, these attacks have been associated with sectors like finance and industry, but our community is not immune from them either. These repercussions can be severe: data breaches, intellectual property theft, and even distribution of compromised research results. So now the question is, how do we bring industry advancements into the open science ecosystem? So scientific software exhibits some unique characteristics that makes it different from other domains. Usually there is insufficient software engineering training within the scientific community, and there is a lack of software quality. Also, there is minimal incentive for robust software functionality because of a publication-centric credit system. But scientific software has also some advantages compared to industrial software. It benefits from an established trust and reputation network through publication records. There's also a limited use of cloud infrastructure, and OCI containers are not dominant yet. But despite these differences, scientific software also has some similarities with other domains. It has large and relies on building blocks like Conda and Python. And it is also growing in terms of using containers and cloud native technologies. So maybe someone says the answer to this complicated problem of managing scientific software is just to put it in a container and put it on Docker Hub. But adoption of containers comes with its own pros and cons. They can be very helpful. They streamline the execution of complex software. You can simply access them through, let's say, Docker Hub, but you need to be careful about reputable sources and up-to-date images. Also, they isolate scientific software stack from the system software stack, which enhances the portability of software. They also offer immutability, but the vulnerabilities can persist. For example, historical software bugs can remain within that immutable container image. So awareness and mitigation of security vulnerabilities are crucial to ensure robust containerized workflows. So we need something more than just Docker Hub to share our software for reproducing publication results. So this is where Soteria comes in and fills in the gaps. So it's going to be a registry for US researchers and collaborations. It's going to be a service focused on meeting the needs of scientific software environments. It's also going to add traceability, so users can see where the container came from or was it signed by a user or not. Additionally, it plans to add reproducibility and makes the software more reusable and accessible. Also, it's going to add visibility to containers and provides information on, let's say, system RPMs and vulnerabilities and such. It also makes scientific software more discoverable. It makes it easy to discover and cite the images. And finally, it's going to provide training and education on the importance of secure software environments. So now that I talked about different goals and different parts of Soteria, let's see how its architecture looks. One part of it, as you can see to the left, is the image creation, which comes from collaborations and users. The other part is the Soteria container registry, which you can see in the middle. And then there's going to be image inspection and then image distribution, which is going to be through HTTP proxies, OSDF, and CVMFS. So now let's see how the registry works. We adapt and utilize open source tools that already exist. So for the registry, we have OSG Hub, which is powered by Harbor. The authentication is done through CI logon, which uses federated identity, and it is not tied to a project. And then the Harbor instance is operated on Path Kubernetes platform. The database has on-site active standby setup, and incremental snapshots are sent to alternate sites and backed up offsite. And then the S3 bucket is also similarly replicated, and it is set to run at the Chicago and the Wisconsin site. You can also see some statistics on OSG Hub to the right. So as of now, we have 52 projects, 430 repos, about 8,000 unique images, 78.4 million image pools, and a storage allocation of around 3.2 terabytes. So now let's see how the identity and user management works and how users get on board. So you can go to soteria.osg-htc.org to register for Soteria. Co-manage integrates with CI logon to provide a user registry for Soteria. Roles identify the degree of vetting a user has gone through, and group membership controls the access to projects on OSG Hub. The initial registration flow allows us to link an OSG Hub user with their ORCID ID and provision that user a private project so they can explore the system. Users can also apply for researcher status, and that's going to give them the ability to create 5 projects, 3 public and 2 private. Also, it gives them the ability to add other Soteria users as members to those projects. The concept here is that each image is tied to the researcher's So Harbor itself comes with a scanner called Trivy, and it lists all the CVEs for you. And you can see a screenshot of it to the top right. But we also started working on CrowdStrike image vulnerability analysis. So there's a screenshot of it, of the vulnerabilities that it lists for an artifact on the bottom right. It is not part of Harbor, but you can connect it to Harbor to scan artifacts. So the long-term vision here is to have each artifact registered as a document in Elasticsearch database. And this is going to trigger a series of analysis tools that run against the artifacts. Some of them will be security related and some of them will be visibility related. For example, can we enumerate and advertise all the software installed in a Conda environment? And then eventually, the results of these analysis tools are sent to the database, and then they'll be advertised as part of the public web page of that artifact. So what comes next? It's going to be image distribution. So Docker pull isn't the end of the story. For each public image, we want to convert them to Singularity and upload them to the OSDF for distribution. And also we want to convert them to flat directory and publish them to CVMFS. On top of that, there's a need for auditing. So let's say there's an interesting image, what was used where? And there's also a need for selective replication. So we're going to provide endpoints that only mirror images which are either signed or they don't have any critical CVEs. And then looking at it long term, Soteria is a research project, so it eventually comes to an end. But OSG Hub is going to have a much longer lifetime. Also, there's no universally accepted way to capture, archive, and assign a persistent identifier to a software environment. But what we want to do is to build tools to provide a smooth path to archive these containers to Zenodo. And this concludes my talk. Thank you for joining.